Hi everyone. Today we're going to be talking about the volume of cones. Now again, we have an unfortunate situation where we can't do our explore activity, but we would be doing this in class. Not with these seeds, but with a cone and a cylinder. What happens is, we'll notice that there's a very interesting relationship between the cone and the cylinder. So we're going to read what it says here. A cone, of course, is a three-dimensional figure. It has one vertex, which is here, and one circular base, which would be here. So it's different from a cylinder. A cylinder has two circular bases, exactly the same, separated by a height. The cone instead has just one circular base, and then it meets down here at a vertex. Okay. So to explore the volume of a cone, Sandy does an experiment with a cone and a cylinder that have congruent bases and heights. She fills the cone with popcorn kernels and then pours the kernels into a cylinder. She repeats until the cylinder is full, and Sandy finds that it takes 3 cones to fill up the cylinder. So this is not a coincidence, this is an actual relationship. If you have, and I have this stuff in our classroom, of course, not with me, so I can't demonstrate for you. If you have a cone that has the exact same base as a cylinder and the same height, the cone is 1/3 the volume of the cylinder, and the cylinder is 3 times as much as that cone. So instead of having to memorize a whole new formula for a cone, all we do is we use the volume for a cylinder and we multiply it by 1/3. So to find the volume of a cone, what we do is we take the volume that we learned yesterday, which was pi r squared h, and we're taking 1/3 of that amount. So to find the volume of a cone, all you do is stick a 1/3 in front, and that's it. Because if you extended this at the same height, it would be 1/3 of the cylinder. And that's exactly why, and it's really true. You can test it out for yourself if you happen to have, which I know nobody does, but if you happen to have a cone that had the same radius as a cylinder and the same height as the cylinder that you had, you'd be able to show that. And I do regret that I have this all in the classroom because I really wanted to show you guys. But that's okay. So we're going to follow the exact same steps that we did yesterday. The only difference is that we're going to have a 1/3 in our formula now. I'm going to show you some options for dealing with that. So to begin, we're going to start off with this first example. We're going to find the volume of each of these cones. We're going to use 3.14 for pi again, and we're going to round our answers to the nearest tenth. First thing I'm going to do is I'm going to write the volume formula like I did yesterday, but remember this time we need to include the 1/3. So it's 1/3 the area of the base, pi r squared times the height. The radius here is 2, it's given, and the height is 8. So now when I plug everything in, I'm just going to have an extra value. So I'm still going to put in parentheses 1/3, and now pi, we're using 3.14, and then r squared is going to be 2 squared, and then h, which is 8. So I'm going to just show you quickly a little trick. If you have a graphing calculator, this does not work if you have a scientific calculator. There are ways to write fractions on a scientific calculator, but I don't have one, so I can't really show you that. But on a graphing calculator, since I know a few of you do have them, you can make a fraction. I'm going to start with my parentheses because I want it in parentheses. But you can make a fraction by pushing alpha y equals, and then it gives you this display. The first one is for a regular fraction. The second one is for a mixed number. The third one is to change a fraction into a mixed number, or vice versa. And the fourth one is to go from a fraction to a decimal. So the only time you really need to use this, and next year you're going to be doing it a lot, So it's good to just try it now if you have it. So you push alpha y equals, and then you push enter for the first one. And it'll give you a little spot to make a fraction. Isn't that nice? So you just push 1, and then you're going to use your down arrow to get into the denominator, and you push the 3. And now you can just push, oops, sorry, I made a mistake. You need to push, I forgot to say this, you have to push your side arrow, and it displays there. You have to push your side arrow to get out of the fraction, then you can close your parentheses, like that. Okay, so let me show you one more time. So you push, if I want it in parentheses, I'm going to push my parentheses first. Now I do alpha, y equals, and I push enter for 1, or you can push 1. And then I'm going to put 1 in for the numerator. And then I go down into the denominator, push 3, and then I push over to get out and close my parentheses. Okay, and now I'm going to continue. 3.14 goes in here, close my parentheses, and then 2 squared goes in here, and then 8. And all at once I push enter, and I get my answer. So this is 33.493 repeating. So we're rounding to the nearest tenth. So I look here and I round up. This is going to be 33.5 inches cubed. And that's my answer. Now I did want to just show you another option for if you don't have a scientific calculator for dealing with that 1/3. What you can do is you can plug in everything else except for the 1/3, and then when you're done, you can divide your answer by 3. Please remember, multiplying by a third is the same as dividing by 3. So what I could do is, I could plug in everything else except for the 1/3. So 3.14 times 2 squared times 8, push enter, get my answer, and now right from there, divide by 3, enter, and I'll get the same answer. So for those of you who are using scientific calculators at home, or if you don't have any calculator that is a higher level technologically, you're just using, like a handheld calculator, that's the route you want to take. Okay? I think I actually have like a very low functioning calculator I might be able to use to show you. So I'll check in a minute after I do this one with you. Okay, so now let's do the second example. So sorry. So I'm going to set up my formula like always. The volume is equal to 1/3 pi r squared h. R equals h equals. So I look down here and I notice that this is a straight line from one end of the circle to the other, which means that's representing my diameter and not the radius. So I need half of that to get the radius, which will be 4. And my height is 9. Notice that the height in a cone is most of the time represented in the middle like this, from the top down to the bottom. There may be times where it's shown off to the side, but most of the time it's in the middle. Okay, so let's get plugging in. V equals, in parentheses, 1/3 times 3.14 times 4 squared times 9. So I'm going to plug it all into my calculator. I'm going to use my alpha y equals again, so I start with my parentheses. Alpha y equals, enter. 1 down, 3 over, close parentheses. Now 3.14, close parentheses. Now 4 squared, close parentheses, 9. And then just push equals, you don't have to do anything else. Okay? And I got 150.72. And rounding to the nearest tenth, that's going to be 150.7 feet cubed. And just to make sure everyone knows, just because we're adding in another number here doesn't mean that this now becomes to the 4th power. It's still just radius times height, so you're still only multiplying 3 things together that have units. Okay, so I'm going to have you guys pause and try these two on your own. Number 4 is an example where the cone is on its side, so try not to get thrown off. Remember that the height is from the vertex to the bottom. So even though it's on its side, this is not the height. This is representing the radius. The height is represented this way. Okay, if you need to turn your page like that or like this to see that clearer, then go ahead and do it. Just try not to get caught up in that. Okay, so go ahead and pause and give these a shot. Okay, so these are the two solutions that you get. This one works out nice. Just be careful because when you look at this example, the diameter is given, so you have to find half of 15. Hopefully you can just do that in your head. It's 7.5. If not, just use your calculator and divide by 2. Plugging everything in, you get 942 centimeters cubed. And I did want to just show you, I did find a scientific calculator, but it's kind of different than the one that we use in class. So I wanted to show you that you have the option of multiplying. Now this one doesn't, you can put parentheses, but it doesn't allow you to put it all in at once. So you may be using a calculator like this at home, and if you do need to use it, I just want to show you what you can do. You might want to wait to do the 1/3 until the end. So I'm going to do 3.14 times 7.5 squared. So in here I have 7.5 squared is here, and that gives me my answer. And then times 16 equals, and it gives me the 2,826, and I need to divide that by 3. So without clearing it out, I divide by 3 and push equals, and there you get the same answer, 942. So it is possible to do this in here. I'll show you again for this one. Number 4, you are given the radius, which is 2, and the height is 3. Remember, if it's on its side, you're going from the pointy end to the middle of your circle, base circle. Plugging in, we get 12.56, and we're rounding to the nearest tenth. That becomes 12.6 feet cubed. Okay, and just one more time, if anyone needs to see this, I'm going to put in, I'm going to leave the dividing by 3 till the end. So I do 3.14 times 2 squared. Now you can do 2 squared, or you can say 4, because hopefully we know that, times 3 equals 37.68. And I'm going to apply that 1/3 by, technically you could multiply by 1/3, but it's just better to divide by 3 on these calculators because the fractions get a little funky. 12.56. Okay, so it is possible to do that here on those calculators. If you have a graphing calculator, I want you getting used to it, so please use it. Now to finish up, yesterday we did the same thing. We had real world examples, so we're going to do one of those. In this case, it's about finding the volume of a volcano, which I thought was kind of interesting. The mountain that's created by a volcano is often cone-shaped. Now I have my picture here, which I didn't include on mine because I couldn't print it out with all the color. So for her geography, of course I said geometry, geography project, Karen built a clay model of a volcano in the shape of a cone. Her model has a diameter of 12 inches and a height of 8 inches. Find the volume of clay in her model to the nearest tenth. Now, just like yesterday, you don't have to draw a sketch, but it might be helpful to, depends on how visual you are. I like to just generally draw one just to be safe. So I know the diameter here is 12 inches, and the height is 8 inches. Okay, so I know that I need the radius instead of the diameter. So when I set this up, the volume is equal to 1/3 pi r squared h. R equals h equals. The radius is going to be half of that, which is 6, and the height is going to be 8. And now I'm going to just plug everything in. 1/3 times 3.14 times 6 squared times 8. And I'm going to reiterate again and stress this, that you guys need to be writing this out the way that I'm doing it, down to writing R and H, down to putting everything in parentheses, okay? Now I'm going to grab my calculator. I'm going to plug this all in. So I'm going to open up parentheses, alpha y equals, enter 1 down 3 over, close parentheses. Now I'm going to enter 3.14 and then 6 squared and then 8. Okay, and then I just push equals and I see 301.44, 301.44, and I'm going to round that to the nearest tenth for less let it rest. So it's going to be 301.4 inches cubed. And that's my answer. Okay. So to finish up, what I'd like you guys to do is the final your turn. And this one's kind of cool because it's based on actual real data. So the cone of a volcano, I don't even know how to say that, Paracutin in Mexico, had a height of 410 meters and a diameter of 424 meters. Find the volume of the cone to the nearest tenth. So if you want to sketch, you can. You don't have to. Remember, you're following these steps, writing everything out the same way that I am, and then use your calculator. So go ahead and pause, give this one a shot, and then come back to check your answer. Okay, guys. So you should get a real big number for this. The diameter is 424, like we said before, so you need to find the radius by dividing by 2. That should give you 212. And after you plug everything in, you get this huge number and round it to the nearest tenth. The final answer should be 19,286,968.5 meters cubed. And that is the volume of the actual cone of the volcano, which is kind of cool. All right, guys, so that's everything for today. I'm going to say one more time. Please make sure you are following my steps and writing everything the way I am. If you need extra paper, remember when you're working if you're working on your tablets or computers, you can add in extra blank pages if you need to. But also, most of you have figured out that you can kind of write off to the side if you're using like a tablet pen or anything like that. And if you're doing this by hand, just use scrap paper and include that picture so that I can see it, because this is what I want to be seeing when I check your homeworks. Okay? All right, have fun finding the volume of a cone.